This is question 21. This is the last question of the June 2019 paper, question 21. This is a rates question. It's a short question. Let's have a look. 3 students carry out a rates investigation on the reaction between bromine and propanone. Sorry, let me just check if this is recording. This is recording. Bromine and propanone. You got the equation there. In the presence of hydrochloric acid, this is a reaction condition under acidic environment. Each student investigates the effect of changing the concentration of one of the reactants whilst keeping the other concentrations constant. The results are shown below. Student 1, student 2, and student 3. So it's asking us explain how the reaction orders can be determined from the student's results and determine the rate equation and the rate constant. That's what we are to do. How can the reaction orders be determined? So this is only worth 6 marks. That's the end of the paper. Let's do one bit at a time. You see student 1 results. They've changed the concentration. So the concentration is changing and it's plotted against time. Now you see rate. The units for rate are concentration, change per second. That's the units for rate. So here we've got the concentration and here we've got time. So the gradient, no matter where you take the gradient, be it here, be it here, be it even here, or even here, or the whole thing, no matter where you take it, the gradient is the same. So if the gradient is the same, the gradient represents the rate. The rate is unaffected by the change in concentration. The rate is unaffected by the change in concentration. So we could, how do we, so this is for BR2. Let's write this down. BR2 zero order with respect to BR2. And now let's give a reason. The reason is that as there is a constant, meaning unchanging gradient, a constant gradient, or we could say a constant rate. So that's BR2, order reaction. Let's look at the next one. This is for, this is initial rate. Now you see, when we have a linear graph like this, a linear graph like this is first order. While we're here, a graph like this is zero order. Remember, this is rate versus concentration. Zero order is like this, and a second order goes something like this. In our case, we are looking at over here. This is a first order reaction with respect to propanone. And you see, another thing is if you were to get the concentration and multiply it by, say, multiply it by 3, the rate would also multiply by 3. You multiply it by 4, the rate will also multiply by 4. So it's directly proportional. So this straight line graph for concentration and initial rate, straight line graph tells us it's a first order reaction with respect to propanone. So we say first order with respect to propanone. And a reason for that is as it is a straight line graph which shows rate is directly proportional to the concentration of propanone. Okay, let's look at student 3 results. With student 3 results, you can see that the concentration of Br2 is kept the same. The concentration of propanone is kept the same. However, the concentration of the H plus concentrations is doubled. Let's times that by 2. And you can see that the rate is also doubled. It's directly proportional. Therefore, it's times 2 to the power of 1. That 1 is your order. So we say first order with respect to H plus. Why is that? Because if you look at the results, when the concentration of H plus is multiplied by 2, rate is also multiplied by 2. Therefore, it's a first order with respect to H plus. From this, ladies and gentlemen, we can derive, let's get a dark purple color, we can derive the rate equation. The rate equation is equal to the K constant. So 0 order with Br2, let's take that up, we won't use that. It's first order with respect to propanone, and it's first order with respect to H plus. It wants us to work out this is the rate equation. It wants us to work out the rate constant. So we rearrange. K is equal to rate over propanone concentration and multiplied by H plus concentration. So we pick any experiment results. Let's just pick experiment 1. We will use experiment 1, 1.6 and 0.2, 1.6 and 0.2. So what's rate here? You know what, it's so easy to make a mistake on this. I'll tell you what that mistake is forgetting this times 10 to the minus 5. So 1.25 times 10 to the minus 5 divided by 1.6 and 0.2. 1.60 times 0.20. Let's just double check that. Yes, that is. That gives you K. We'll work out the answer of K. That gives you K is equal to 3.90. Actually, 3.9. I'll say, Naya, I'm making a video. Apologies for that, ladies and gentlemen. 3.91 times 10 to the minus 5. Yep, and the mark scheme supports that. And now, whenever you give the rate constant, you always give the units. And the units for rate are moles per decimeter cubed per second over concentration times concentration. This cancels out with this, and so the units you'll get is mole -1, and because you're dividing it by mole, and dm to the -3, which just becomes a +3, and you've got S -1. Yep, and the mark scheme supports that, and it says you can write this down in any order. Ladies and gentlemen, this is the end of this question. This is the end of this paper, and this is the end of for this academic year for China Daily Videos. Your exam is tomorrow, Monday, 10th of June. I wish you the very, very best of luck, and I hope you will give your very best and that you've prepared thoroughly with this. And, you know, I don't want to be over prescriptive with tips on the exam, but one thing I do want to say is please read carefully, read the questions carefully. You always, you know, make silly mistakes if you don't read questions carefully. And time smart. It doesn't matter if you get a mark for a difficult question or a mark for an easy question. The main thing is, you know, be time smart. If you're spending too much time on one question or one mark, be it in the multiple choice, skip it and come back to it. And by that way, you'll find that you'll do the exam in an efficient manner, and that will leave you time at the end to go back to them. And because you've had a bit of processing time, you'll find that you're in a better position to answer them. With that, class, best of luck. Take care, and I'll see you soon.